Hello and a warm welcome to today's webinar, Green and Sustainable Chemistry from Objectives to Action, organized jointly with the United Nations Environment Programme. I'm Hannes McNulty, Senior Green Industry Advisor at the Green Growth Knowledge Partnership, or GGKP as it is better known, and I would like to thank you for being with us here today. Now, before we get started, I'd like to take a brief moment to introduce GGKP, a global network of experts and organizations dedicated to providing the policy, business, and finance communities with knowledge, guidance, data, and tools to transition to an inclusive green economy. If you aren't already familiar, I would encourage you to visit one of our 3 knowledge platforms: the Green Policy Platform, the Green Finance Platform, and the Green Industry Platform. I'm excited to announce that GGKP has launched the Green Forum, an online community space for sharing and discussing insights on a range of themes and issues related to a sustainable economic transformation. There will be certainly lots of discussion on green and sustainable chemistry, so do consider registering now at thegreenforum.org. So today we're fortunate to be joined by some very innovative thinkers, economists, and scientists. Audience members are, as always, invited to submit questions and comments throughout the discussion, as it's really a fantastic opportunity to engage directly with the panel. As well, after the webinar, we'd really appreciate it if you could take just a few minutes to complete our short survey. Your feedback really is important in helping us shape future webinars. Please note also that a full recording of the webinar will be available on our website at ggkp.org/green sustainable chemistry shortly after this broadcast. You can also stay in the loop about future GGKP webinars by signing up to our newsletter at ggkp.org/subscribe. With that, it is now my pleasure to introduce the moderator for today's event, Monica McDellis, Chief of the Chemicals and Health Branch from the Economy Division at the United Nations Environment Programme. Monica is an environmental psychologist with a doctorate in plant biotechnology and genetic engineering. For the past 30 or so years, she has worked extensively in applied science and technology innovation in the fields of agriculture, forestry, and coastal and also marine development. So now, without further ado, Monica, I'm really delighted to welcome you to today's webinar and hereby turn it over to you.
Thank you very much, Hannes. And maybe just one slight correction. I'm not a plant psychologist, I'm a plant physiologist. But anyway, do that as it may. Thank you for according plants that sentient acknowledgement. Okay, welcome everybody, and welcome to the GGKP webinar for today. And thank you again to GGKP for organizing this. We have a very interesting discussion ahead of us today, and it's really about innovation and sustainability in chemicals. And as we all know, chemicals are everywhere in our daily lives, and we encounter them every day, and they contribute to our well-being, but they can also have some negative effects on our health and well-being in our lives as well. In the second edition of the Global Chemicals Outlook, there was a conclusion that to minimize the adverse impact of chemicals and waste, very ambitious worldwide action must be taken to find solutions to these impacts. One of these solutions is to transform the way we make chemicals and use chemistry, in other words, to move toward green and sustainable chemistry. The Global Chemicals Outlook second edition also highlighted that green and sustainable chemistry education and innovation are drivers of change that can be scaled up through enabling policies to reap benefits of innovation in chemicals throughout the value chains of chemical production and use, and from a circularity perspective. Green and sustainable chemistry innovations, technology, and tools can contribute to the overall sound management of chemicals and waste, while also addressing large-scale sustainability challenges. Innovation can and must play a key role in responding to the triple planetary crises we all face, notably from pollution and the role chemicals and waste plays in contributing to global pollution and health burdens, but also the impacts of chemicals in the environment on climate and nature. In response to a resolution adopted by governments at the 4th session of the United Nations Environment Assembly in 2019, UNEP is working to promote green and sustainable chemistry through synthesizing global best practices into manuals. The first of these manuals, entitled Green and Sustainable Chemistry, a Framework Manual, is now available and is centered around 10 objectives and guiding considerations to inspire and guide a shift to green and sustainable chemistry. Today, we've gathered here chemistry experts from industry, academia, and government to spark a discussion on how we can work together to take the next step from these green and sustainable chemistry objectives to green and sustainable chemistry action. The format for today's program will include a scene-setting presentation, followed by remarks from industry and civil society representatives, and a question or two from you, the online audience. We'll then have an engaging panel discussion among our 7 panelists, so stay with us. We have a great lineup for the next hour and a half. Without further ado, I'd like to introduce our first speaker, Achim Halpaap, to give us his presentation. Achim Halpaap is the lead author of the Framework Manual and former head of the Chemicals and Health branch at UNEP. So Achim, over to you.
Well, thank you very much, Monica, and thank you to all participants around the world to participate in the seminar. I'm particularly excited that the Green Growth Knowledge Platform took on the topic of green and sustainable chemistry because it is so important to take the green economy story to particular areas, and chemistry, I think, is one where through sustainable chemistry, sustainable material management, and also sustainable product design, some major green economy challenges can be addressed. Today, next slide, please. I will present you the UNEP Framework Manual on Green and Sustainable Chemistry, and I already would like to thank many of you for engaging in its preparation, and also the German government for supporting this work. I will briefly introduce why do we need to scale up green and sustainable chemistry innovation, outline and provide key messages of the manual that UNEP recently published, but also conclude with some opportunities to scale up action through green and sustainable chemistry roadmaps by all stakeholders. Next slide, please. This is a chart I want to start with that was presented by the International Resource Panel a few years ago. It shows the global extraction of materials use from 1900 until 2050. And you see here the year 2015, more than 80 billion tons of materials were extracted and used. And the growth is exponential and it's expected to double again by 2050. Now, a significant amount of these materials are dependent on chemicals. They end up to be chemical products, made through chemicals. And the interesting number is that only about 10% of the total materials extracted and used currently is being recycled. So this most significant portion remains on Earth today in terms of products, in terms of waste materials. Some of it is incinerated. A lot of it we do not know where it's going to. Next slide, please. Now, in terms of the chemicals that are on the market, a study by the European Environment Agency estimated that approximately 60% in terms of volume of chemicals on the European market are hazardous to health, about 30% are hazardous to the environment. Now, of course, we all know labels and many of these chemicals can be managed safely, but the Global Chemicals Outlook also refers to significant gaps in the chemical management infrastructures around the world. Therefore, significant human health and environmental concerns and impacts are still witnessed. Next slide, please. The Global Chemicals Outlook, if you're interested in more data on this, systematically assessed and documented the environmental and health impacts caused by chemicals. And part of that story is an estimate by the World Health Organization in 2018 that per year more than 1.6 million deaths can be attributed to negative impacts of chemicals. In particular, fetuses, infants, children, pregnant women, elderly, and the poor are the most vulnerable affected. The Chemical Outlook also systematically documents the impact of pollution that threatens ecosystem services, for example, pollinators or coral reefs. And economists have now put some of the impacts into financial data, and the studies show that the externalities associated with lack of chemical management are in the high tens of billions of dollars annually. Next slide, please. Now, the Global Chemicals Outlook also forecasts the growth of the chemical industry, and this is expected to grow from about $3.5 trillion in 2017 to about $6.6 trillion in 2030. So consistent with the graph from the International Resource Panel that I showed you earlier, the growth of the chemical industry is projected. And if we put the lack of chemical management infrastructure globally together with the projected growth of the chemical industry, we arrive at the main conclusion of the Global Chemicals Outlook, and that's the following. Next slide, please. Business as usual is not an option. That is the 10-second message that the Global Chemicals Outlook provided. It also tells, though, not only the legacy issues associated with the old chemistry, but as Monica pointed out, also outlines the opportunities that chemicals can provide. Next slide, please. In part 5 of the Global Chemicals Outlook, the statement is made that innovations in chemistry have significant potential in advancing sustainable development. And you see a growth in green chemistry market from 2011 to 2020. It is relatively small compared to the traditional chemistry, but it is growing exponentially. And the work that we are now talking today is aiming at accelerating the growth path of chemistry that is fully sustainable and meeting green chemistry criteria. And that opens up the potential of chemistry to help achieve major sustainable development objectives, including, for example, SDG 2 on zero hunger, SDG 6 on water and sanitation, SDG 12 on sustainable consumption and production, and also the SDGs dealing with climate change. Next slide, please. So this positive story that the Outlook provides led to a mandate by the United Nations Environment Assembly to develop manuals on green and sustainable chemistry. So this framework manual is the first attempt to implement that mandate. The manual introduces a wide range of scientific, technical, and policy aspects of green and sustainable chemistry. It helps to facilitate learning, but at the same time also aims at bringing together various discussions that have taken place on the topics around the world and facilitate a common understanding. Ultimately, it is aimed at stimulating stakeholder action and fully unveil the full potential that chemistry has in supporting the 2030 agenda. But the key is here compatibility of chemistry with all 3 dimensions of sustainability: environmental, social, and economic. So it's not either or, it is and. For those that are not interested in reading the 100-page manual, we do have an executive summary available, and also we do have a specialized manual on green and sustainable chemistry education to dive into the question in much more depth, how to change the behavior of young innovators and chemists to engage in a different type of chemistry innovation than in the past. Next one, please. At the heart of the manual are 10 green and sustainable chemistry objectives and guiding considerations. And we were inspired in developing these 10 objectives by some of the work on green chemistry. And many of you know the 12 principles of green chemistry developed by John Warner and Paula Nestis. Further work was done by the OECD on sustainable chemistry in the early 2000s. Then more recently, the International Sustainable Chemistry Collaborating Center and Klaus Kummer and colleagues have developed sustainable chemistry concepts further. So these 10 objectives are meant to bring it all together in something that decision makers, researchers, heads of laboratories can place on their walls to be reminded what type of chemistry should we try to innovate in order really to meet sustainability criteria. And these chemistry objectives, they're starting with molecular design points like minimizing chemical hazards in designing new molecules, and they end up with a 10th objective, which is ensuring that chemistry innovations address sustainability challenges. So it is not innovation for the sake of innovation, but innovation to address societal problems. And in between are many different, more specialized objectives, picking up different policy frameworks also that exist, which relate to chemistry. For example, one objective is helping to ensure that chemistry is helping to ensure a non-toxic circular economy. These principles are not around individual substances, but they already touch product design, they touch sustainability of production processes, and take on the life cycle perspective. So we feel that if innovation is fully compatible with these 10 principles, significant changes can be made in transformation through sustainable chemistry. Next slide, please. Now, the objectives are at the heart and all featured in chapter 3. So if you're interested in reading more about each of them, please go to the respective chapter. But the manual is broader in nature. It's trying to embed the story that we are telling in the 2030 Sustainable Development Agenda. So these linkages are explained in chapter 2. Chapter 4 is also taking the topic to a more scientific and technology level and outlines some of the scientific areas that are relevant to green and sustainable chemistry. For example, ensuring sustainable feedstocks such as using biomass from waste as a feedstock for chemicals, non-toxic alternatives such as using water-based solvents instead of organic solvents, but also process innovation such as replacing toxic heavy metals with biocatalysis. So I'm not going to go into detail. This is not a scientific lecture, but if you're interested in these topics, chapter 4 provides some insights. We also spent significant time in the manual to look at the enabling frameworks needed to advance sustainable and green chemistry innovation. So in chapter 5, several enabling instruments and policies are discussed, such as life cycle assessment, such as sustainable supply chain management, or corporate sustainability strategy. We also then in chapter 6 take the topic to enabling sectors, the innovation sector, the financing sector, the education sector, are all enabling sectors. If they pick up some of the objectives I just presented, can make a major difference in accelerating innovation. And last but not least, we have a chapter on metrics, how to assess if progress is being made. Next one, please. Now, of particular interest for the green economy community is, I think, the topic of innovation. And this just shows here how complex the innovation ecosystem is, and nurturing new startup companies that are picking up green and sustainable chemistry objectives is key to this. And many actors need to work together to create, I think, a new wave of innovation, to get young people, young scientists excited about these opportunities. Next one, please. Secondly, just to give you another example about the enabling environment, is to get the financial incentives right. And in the Global Chemicals Outlook, we discuss, and as well in the framework manual, we discussed a number of financial incentive mechanisms which could be applied specifically to the chemistry agenda. So I encourage all of you that work on economic instruments, financial instruments, financial incentive schemes to think through how can you bring in some of the green and sustainable chemistry objectives into your work and to your policies. Next one, please. Yeah, ultimately, the manual seeks to encourage action by a wide range of stakeholders, and the final chapter is encouraging the development of green and sustainable chemistry roadmaps. There are exciting examples out there. The American Chemistry Society is developing a roadmap on green and sustainable chemistry education. Many universities are initiating green chemistry action plans. Perhaps we hear a little bit more about it. And we hope that many more companies, governments around the world pick up these ideas and take a strategic approach to transforming chemistry and creating a new, exciting area of innovation based on the principles and objectives that the manual provides. Next slide, please. Yeah, with this, I'm encouraging all of you to consider how can you take action to advance the story that we are outlining through the manual. And I would like to thank you very much for your attention today. And I look forward to the panel discussions and the various questions. Thank you very much.
Great, thank you very much, Achim. And one of the things that I'm learning is there's a slight delay on the line here in terms of when things turn on and off. So I ask all of us to indulge a little bit of time here. Thank you for setting the scene, and we look forward to some questions from the audience. And I already see some popping through, so that's wonderful. What I'd like to do now is move to our two sort of panelists who will provide some remarks from two different perspectives. So we'll have an industry perspective first, and then one from civil society. So I'm going to now turn over to our perspective from the industry side of things, and I'd like to introduce to you Mr. Rafael Cayuela. He's the chief economist at the Dow Chemical Company and author of the book, The Future of the Chemical Industry by 2050. So Rafael, over to you for a few remarks.
Thank you, Monica, and thank you as well. Can you hear me well?
Yes, we can hear you fine.
Okay, perfect. Thank you very much for the invitation, and also thank you very much to the Green Growth Knowledge Center for this amazing event and having the opportunity to share some industry perspectives on how do we see green and sustainable chemistry. While let me also congratulate you for the manual and the framework. I think something that is obviously very, very important, and I've been in contact with Achim in the past, working with UNEP, and I think let me congratulate you for a fantastic tool that I hope it will become something that we can move globally as well. So let me start, next slide, please. Let me start by sharing some of the things that actually we are sharing in our industry, not too much to comment today on green chemistry and sustainability, but actually to comment a little bit on what kind of messages we are sharing in our industry. I think the first one, this is a chart that most of you have been familiar with that, but I think it's a very good chart to illustrate a little bit where we are today. And I think where we are today as an industry society is that we are living, of course, truly times. In the middle of once-in-a-century pandemic, in the middle of once-in-a-century or maybe the second largest economic recession in this century, and probably still, because it's still not finished, becoming the largest economic recession of this century after the Great Depression. We are now, as a society, preparing ourselves for two major events, of course, that they are actually not even once in a century, but actually once more over than thousands of years, like climate change and biodiversity collapse. And if this is not enough to really think about true historical times, I think we are at the beginning of the arrival of the fourth industrial revolution, something that the World Economic Forum was calling as a digital revolution, and they were a great job of calling the arrival of exponential technologies and digital technologies. But we in Dow, we tend to think about the fourth industrial revolution in a more holistic manner as a three converging revolutions: the sustainable revolution, the digital revolution, and the social revolution. So let me go to the next slide, please. So I'm not going to talk a little bit about all of this, but I'm going to talk about one that actually is very close to all of you, and it's actually the latest report on the UN share of the state of the global climate. And why do I want to start with this one? I think, of course, you are very familiar with this one, but I think this one is basically telling us that in the fight of climate change, not only things are accelerating, but actually more efforts are required. And I wanted to start here our journey to sustainable chemistry and where green chemistry and sustainable chemistry can play a role to highlight the biggest, of course, after biodiversity and inequality. These three major issues are going to be concentrating our efforts over the next decades, correct? But on the first one, I think it was very important to highlight that, of course, not only is very welcome that actually major economies like Europe under the European Green Deal, China, and more recently, obviously, United States are actually putting very strong pledges against carbon neutrality by 2050 or 2060. I mean, those are obviously very welcome steps, but as we know, this is not enough, because in reality, what you can see in this chart is still we have a significant gap from where we are currently projected to be versus where we are supposed to be under the carbon neutral scenario. And why this is important? I think this is very important not only because of the consequences on climate change and biodiversity and many other areas, but because we actually realize that in order to go through this transition, and I think that's why I'm very pleased both with the invitation from the Green Center for Knowledge, Green Center for Knowledge Sharing, that I think is a great initiative to start looking into frameworks, as well as the framework for green and sustainable chemistry. Because the reality is that to achieve what we have to achieve in a very short period of time, in a very efficient manner, we need to have a very coordinated action, and that's why frameworks are very important, enabling frameworks, transition frameworks between both supply, demand of citizens and financial institutions. And I'm very pleased to see that already in the green and sustainable chemistry framework. So let me go to the next slide. Having said that, as we start building these important frameworks, we are actually, I mentioned before, it's very important to recognize that beyond the sustainable revolution, we have two additional revolutions. One is, of course, the digital revolution. And I'm not going to go into details into what does it mean digital revolution, correct? Because it basically means many, many things in many, many different angles. Perhaps one important element, as we know for exponential technologies, is that one simple element can already withdraw significant amount of disruption. This is the fact that actually by 2028, the computational capacity of one computer would be equal to the computational capacity of one human being, and probably the computational capacity of one computer would be equal to the computational capacity to the whole mankind over the next decade. And of course, that will drive significant amount of innovations and disruptions, positive disruptions if we are able to channel that into the right sustainable framework. So hopefully that's what we are gonna do. But if we don't do that, of course, we'll have also equally disruptive efforts. But certainly, this is an area that we need to realize that actually the digital and the fourth industrial revolution can be a massive tool for us to move into any of the sustainable developments we have, including green and sustainable chemistry. So next slide. So then you would say, what is the conclusion for us? And I think the conclusion for our industry is basically we are in the middle of a massive transformation. It's a transformation that actually have at least two legs. I'm going to be talking only about two today. Is that basically sustainable and digital, and it's going to poise basically the acceleration into new growth, as Achim was already sharing, and new growth and innovation patterns and business models. So if you look at into the sustainable transformation that our industry is going, indeed is already alluded before, we are going into multiple simultaneous transformation at the same time. We are moving into a more carbon neutral production. We are moving into, of course, more fully circular business models. We are also moving into safer and healthier chemicals for the good of society and the environment. And this is, of course, a journey. And of course, we will move into a new wave of value and innovation. Ultimately, what we are going to see is that when we talk about ESG criteria for corporates, ESG criteria are going to be gradually moving down from corporate into products. And this is a journey that hopefully takes less than expected, but it's a journey where the industry is heavily embedded. And I think, again, as I mentioned before, these kind of frameworks can be very useful to accelerate the implementation of this transformation. Having said that, this is only part of the transformation. Let's go to the next slide, next click. I think it's very important to recognize that this is happening at the same time that we are confronted with a digital transformation that has massive implications in multiple ways. Not only because we are going to go moving up in terms of digital technologies and computational capacity, is because some of these things will start creating significant room for opportunities. We will start, of course, looking into the basic things, moving into digital manufacturing systems or digital supply chains, enhanced customer service or enhanced customer satisfaction, employee satisfaction, and basically big data on marketplaces. But as we move into artificial intelligence, blockchain, 3D printed, we also go into quantum chemistry, eventually synthetic biology. All what we are seeing is basically a new wave of innovation and business models for our industry. So if you can click now all the different things here, basically I think we are in the early days of a transformation of our industry, where we need to recognize the value of today is to a large extent not the value of tomorrow. Next slide. You can click all of them, there are 3 or 4. The industry of today is not the industry of tomorrow. The crackers of today are to a large extent not the crackers over the next decades. And ultimately, the molecules of today will be also to a large extent not the molecules of the future. So with all that in mind, I think we are, please, you can click all of them. I think we are again in a massive period of large and disruptive opportunities for our industry that they will provide significant amounts of growth and as well innovation and business model. So just to finish in a positive note, and then we can take some questions. Next slide, please. As I said, I think COVID-19 and where we are on these unprecedented times has reminded us that nature is much more powerful than humans. And I think that was a very good, despite of all the negative impacts, of course, of COVID around the world. I think it's a good reminder for all of us that actually, again, nature remains much more powerful than humans. But I think more important, I think, as we move into the fourth industrial revolution, I think we have an obligation to restore the balance between nature and humans. And green and sustainable chemistry would be at the core of this revolution, as it has been at the core of any other revolutions. Chemistry is at the core of that. I'm very excited to see how the new technologies will help us to really discover a longer business molecular universe, how actually we design the molecules of the future, and ultimately, I think how we all together design the sustainable future that we all want. So I think we are, as an industry, we welcome very much this exercise. And as I said, we are very excited because I do believe that we are really, it's very excited to be in chemistry today and contribute to this massive transformation that we have to go through as a society. Thank you very much.
Thank you, Rafael. And I think there's a lot of interesting information that you've presented us there in a very forward-looking perspective that will stimulate a lot of questions for sure. So thank you for that. What I'll do now is I'll turn over to our next presenter, who is Tatiana Santos. She's the Policy Manager for Chemicals and Nanotechnology at the European Environmental Bureau. The EEB is the largest network of environmental organizations in Europe. Their chemicals work includes improving chemical legislation, ending pharmaceutical pollution, and circular economy transformations. So Tatiana, over to you.
Thank you, Monica. Hello, everybody. First of all, I can only thank the authors for this excellent and important report. It's very important time to have this discussion, and therefore we also thank you for inviting the EEB to bring the civil society's perspective to this discussion. The starting point in our view is to recognize that we are not in a good place. I missed in the picture presented by Rafael maybe bigger wave that is the pollution. The UNEP's report this year, actually called Making Peace with Nature, highlights that humanity is waging war on nature by changing climate, destroying biodiversity, and polluting our bodies and our environment. So pollution is one of the 3 main threats to our planet and survival. Today, industrial chemicals pollution has already reached the most remote corners of the globe, from the deepest oceans to the highest mountains. Man-made chemicals can be found in the water that we drink, the air that we breathe, the food that we eat. Toxic chemicals are weakening our health, undermining the circular economy, contributing to climate change, and amplifying biodiversity loss. Industrial chemicals have permeated our bodies to the point that the researchers describe babies born pre-polluted. This situation is no longer acceptable, and I think we all agree on that. We are already late to act. So it's very important to take urgently action to solve this problem. If we want to protect current and future generations, we need a deep transformation. And as highlighted today by Achim and also in the report, business as usual is no longer an option. And by business as usual, we don't only refer to a future design on chemicals, etc., but also how we are currently regulating the use and production of chemical substances in the world. We need this global transformation that goes towards toxic-free environments by phasing out the current chemicals that are used and are harming our environment and our health. We need to clean up the legacy pollution that is already there. And of course, we need to also look into the future and develop future-oriented policies that ensure pre-market design of the chemicals that are going to be placed on the market and therefore on the environment. So they are green and sustainable by design. In our view, no chemical that is proven to be safe and sustainable should be allowed in the market in the first place. And this is the deep transformation that we think is very important. In the EU, in the European Union, we have now the Green Deal, and in particular, the Chemical Strategy for Sustainability, that it's marking a pivotal moment in the story of the chemicals policy in Europe, since it puts a zero pollution ambition and toxic-free environment goal front and center of the EU policies. It is very much focused on two pillars. One is banning the most harmful chemicals, and in order to protect citizens and the environment, and also boosting innovation for safe and sustainable chemicals. And I think these together they need each other, and they are very important together. There is growing evidence that strong laws that phase out harmful chemicals boost green and sustainable chemistry innovation. Because they set a very clear criteria on which are the unwanted properties that we don't want, and that sets a priority for phase out. And this also gives a clear sign to chemical producers and predictability to which chemicals wouldn't be a good idea to be produced, because sooner or later they would be regulated and banned. In Europe, we have a clear example on this with the main chemicals regulatory system, which is REACH, the authorization process. It's been proven to be a very powerful driver of green and sustainable chemicals, because it lists the so-called substances of very high concern, and the goal of this procedure is to substitute chemicals that will be phased out in Europe. The NGO SEAL has published a study called Driving Innovation that showed this invention trend that has been intensified in the different steps of the regulation in Europe. That's a quite interesting report as well. Also wanted to highlight that strong laws also need to give incentives for green and sustainable chemistry, incentives for these wanted chemicals, but also it has to disincentivize the production and use of hazardous chemicals. And for this, economic instruments are key, as highlighted by Achim before. Finally, wanted just to mention some approaches that we believe are needed to promote the adoption of green and sustainable chemistry. First of all, supporting and coherent legal framework is key, as I mentioned before. It should identify unwanted properties of chemicals. Ideally, it should do so groups of chemicals in order to avoid regrettable innovations or regrettable substitutions. It's very important also the rapid phase out of groups of chemicals. We need to start by the most harmful ones. We need to get PFAS out of our bodies and our environment. We need to phase out endocrine disruptors. We need to urgently protect our children playing with toys with toxic chemicals, etc. Second, it's important also the enhanced transparency is key, that this information on substances in consumer products is empowering consumers to demand safer products, and it would be another driver for safer products. We need to boost and support substitution and green innovation. Technical assistance, etc., are very important. Fourth, awareness, information, training, and education are key as well. And finally, as I mentioned before, economic and financial support that incentivizes the chemicals of the future. At the end of the day, there is no future producing hazardous and obsolete chemicals. The future is on green and sustainable chemicals. Thank you. I'm looking forward for the discussion afterwards.
Great, thank you very much, Tatiana. I'm just waiting for, there I am back up again. Thank you. I think those have been two fantastic perspectives that we've had, both from industry and from a society perspective. And what I'd like to do is just pause here for a minute, because there's been some really good questions that have come up in the chat box. And so I'm going to perhaps throw this one out, and maybe Achim, you might want to take an answer opportunity to this one. We have a question from Khadija Al-Houdi. Why is the danger of chemicals still so high, since many international conventions and protocols are dealing with their reduction and substance management, sustainable management and commerce? So Achim, maybe you can sort of weave in a little bit, having had some experience certainly with UN, around the role that the MEAs and the conventions play. And then I've got a couple more questions, and then we'll move on to the next phase of our panel discussion. Achim?
Excellent question. Thank you, Monica. And indeed, during the 90s, a number of very important international legally binding instruments were developed, such as the Stockholm Convention, the Rotterdam Convention, later on also the Minamata Convention dealing with mercury. Now, all of these conventions only focused on a small number of chemicals and focused on very specific purposes, such as persistent chemicals, or in the case of Minamata, on one single chemical. But I've shown that more than 20,000-30,000 chemicals are still on the market which have hazardous properties, and those international agreements have not covered all of them. That's also why UNEP initiated a strategic approach together with stakeholders on international chemicals management, which tried to address these many other chemicals which are still on the market, but are still causing problems. And every day we're hearing new stories about the problem areas. This strategic approach is now going to another phase. It's looking at chemical and waste management beyond 2020. And all of those who are interested in shaping these new global policies are encouraged to go to the SciChem website and pick up on the discussions how to set goals and targets for the next decade or two dealing with chemicals and waste. So there's an opportunity to deal with the unfinished business.
Great, thanks for that, Achim. And I think it's really important to notice that and to acknowledge that we're not sort of alone in this. There are lots of efforts going on around the world, including with governments, and a lot of action does need to be taken, and there are instruments for that. I have another interesting question here, and perhaps Tatiana, you might like to take this one. You mentioned in your presentation the importance of economic instruments and incentives for green and sustainable chemicals. Can you perhaps give us a bit of an example of what you mean by this, and perhaps expand a little bit on that? I think that linking these sort of economic incentives to making the change and the transformation, given that we haven't made progress, up to this date to the extent that we would like to. Perhaps you can give us an example or two.
Yes, thank you for this question. We are concerned that the current systems are not sustainable. They are not economically sustainable because pollution costs are externalized. So at the end of the day, polluters don't pay for the pollution that they are causing, and it is the citizens who are paying for this cost of pollution, but not only, but also it is citizens who pay for the chemicals control and enforcement costs, which are very costly, as the competent authorities knows well. So in order to make this system sustainable, we believe that the polluters pay principle application is key. It's key that this system also incentivizes and promote and support alternative providers and companies providing good solutions for the society, but also penalize the laggards that are polluting our bodies and our environment. And we believe that, for example, a fee that is paid by industry that is making profit on putting chemicals on the market, in order to pay for the chemicals control and enforcement by the authorities, and also to pay for the health-related and cleanup costs of pollution, is very important. So we believe that the system has to have both this sticks and carrots system, no? Where the carrots are economic incentives and even supporting companies to move towards toxic-free environment, but also we need to penalize the laggards. And there are models that we like, for example, that is a bit of a win-win model, like the Toxic Use Reduction Institute in Massachusetts, where companies using hazardous chemicals, they pay a fee, and this fee is used by a Toxic Use Reduction Institute to support these companies to move towards the transition to zero pollution and toxic use reduction. So yeah. It's very important to study these different elements and instruments in our view.
Okay, no, great, no, thank you, and I'm sure we'll hear some more on this particular topic, because it is something that that is interesting to certainly the audience, but to have those concrete examples. And I'll just take one more question from the audience, because we want to make sure that we're also engaging our audience as well. So here's a question that perhaps, Rafael, you might want to tackle. How do regulators engage the relevant stakeholders to promote green and sustainable chemistry through, say, a science policy framework? So can I ask you to perhaps make a few comments on that, and then we'll head off into our sort of roundtable with the rest of the panelists. But I think just from your presentations, this one might be a good one for you.
Okay, sorry, can you hear me now? Yes, sorry. Thank you for the question, and indeed very important question. And I think as has been also discussed by Tatiana and Achim, I think it's very important to have a very strong coordination. I think if I take the report from the UN report on climate change, that actually we could do it as well for materials, as alluding very rightfully. The reality is that we have very little time and plenty of things to do. And I think this is something that indeed has to be done by firms, financial system with the right incentives, citizens having the right level of empowerment and transition, and transparency to take the right decisions. And I think the engagement between regulators, civil society, and firms and governments is very important. And I think, as I hope you saw in my presentation, we are also trying to stimulate that. We actually released in the European Chemical Industry CEFIC Association, we released 2 years ago what we call the CEFIC Mid-Century Vision, that actually was alluding about all these different challenges. And again, this is a journey, but certainly I think all parties are, as Tatiana was saying very rightfully, I mean, those are very important things that we need to tackle, and we don't have time to lose. So I think it's very important that we stream the collaboration and we work together on doing that. I think the collaboration is good, but it should be even better and can be better once we start defining these frameworks moving forward.
Great, thanks for that, Rafael. And I think, again, this will stimulate some more questions in the chat box. I think what I'd like to do now is keep us moving. We have a number of other panelists that I think we'd like to hear from, but I really want to thank Achim and Rafael and Tatiana for really setting the scene and for putting some really thoughtful information out there for all of us to consider as we hear the rest of the panel interaction. So what I'd like to do now is to introduce the rest of our panelists. We have some wonderful people that I'm sure will add a different dimension to our conversation. So we have with us Amy Cannon, who is the Executive Director and Co-founder of the Beyond Benign organization. Hi, Amy, and welcome. We have Bob Diderich, who is the Head of the Environment, Health and Safety Division at the OECD. Bob, do you want to pop up and say hello? Great, hello. Fantastic. Super. We have Vanya Zuin, who is a Professor of Green and Sustainable Chemistry at the Federal University of São Carlos in Brazil, and a visiting professor at the University of York in the UK and Leuphana University in Germany. Hi, Vanya, nice to see you. And we also have with us Vic Pena. Vic, do you want to come on and say hello to everyone? And I'll give you guys each an opportunity to make a comment, just to sort of set the scene from where you're coming from. Hi, Vic, thank you very much. So can I sort of go around and ask Amy if you can just give us in your introduction just a key message on green and sustainable chemistry, and then everybody will do that, and then we'll go into some more in-depth questions. So let's hear your perspectives in about a minute or two.
Thank you so much, Monica. Thank you so much, Monica. This has been just a wonderful discussion so far, so I'm really happy and honored to be invited and involved, so thanks so much. Systemic, so my perspective is really around chemistry education, as our organization is really focused on green chemistry education and addressing sustainability at those earliest design stages. Systemic change in chemistry education is really required and necessary to support the growing global demand for greener and more sustainable chemical products. You know, as Achim mentioned, chemistry is central at solving so many of the global challenges that we face today. And really, again, green chemistry education addresses that sustainability at the earliest design state or phases really of that value chain, and it maximizes impacts. So if we're not better preparing scientists with these new skills and better preparing them to be able to tackle these challenges, then we're not going to be able to realize real change. So thanks so much.
Thanks. Waiting for my microphone to go on. There we go. Great. Thanks very much for that, Amy. Bob, do you want to give us also a sort of a position statement from your side?
Yeah, thank you very much. So I was very impressed by Rafael's presentation. I'd like to just briefly jump up on something he said. I think what the challenge chemical industry is facing today is what is the chemistry needed to tackle climate change. And I think as his presentation has shown, there is going to be a huge wave of innovation that is going to come out of chemical industry in the next couple of decades. And so while big companies like Dow do have the concept of sustainable chemistry in their mind when developing those innovative new solution, that might not be the case everywhere in all companies. And so let's say one of the ways to get there is to ensure that all countries in their innovation policy integrate the safety aspects. and the previous speaker have mentioned a number of tools already, such as economic instruments and a few more. I'll mention another one, which is stupid simple and which we tend to forget, is that all countries will need to have to implement basic chemicals management systems to further the issue. I mean, there's not going to be substitution in countries if there's not going to be any regulation. So rolling out basic chemicals management systems throughout the world that has a systematic approach at all of the chemicals which are on the market is probably going to be one of the basic issues that we will need to tackle. I'll just say one more word. For the concept of green and sustainable chemistry to be credible with the public, the concept of safer chemicals, the concept has to produce safer chemicals. Otherwise, the whole concept is not going to be taken up, and it will lose credibility in the end. Even though the concept of sustainable chemistry is, of course, much vaster than just safer chemicals. So I was very pleased to see in your manual that the first two objectives were really focusing in on the aspect of safer chemicals. So that has to be the first deliverable of the whole concept. Thanks.
Great. No, thanks for that, Bob. And I think we'll have an opportunity to explore that. We've got about a half hour left on the panel, so we've got some time to pick this up. But let's hear a couple of more statements. We have to hear from Vanya and then from Vic. So Vanya, can I ask you just to give a couple of framing sentences from your perspective, and then we'll get into more detailed question and answers.
Yes, first I would like to say thank you very much for this very nice event and very important discussions, and I'm really happy to be here with you too. And well, I have some bullet points to share with you, but I think all presentations are really integrated, as we can see, and as you have, I think Achim just pointed out, I would like to highlight that innovation in green chemistry, I would like to, let's say, not separate, but to put together green chemistry and sustainable chemistry. But innovation in both means that we need to have highly qualified professionals who have critical inter-transdisciplinary and system thinking mindset. So what is necessary to do that, or to have such kind of people? That I think they are actually citizens. So we need to think about the university roles, because this is right now we have a pandemic. So what we are doing in our universities and how to integrate all sectors all together to promote and to understand deeply all these concepts all together. And I think the key message would be how to integrate all sectors, how to face the challenges that we have today, but we will have more in the near future and I would say long-term future. And well, I have some, like I mentioned before, main ideas to share with you, but by now I would like to highlight and to put together green chemistry, sustainable chemistry, and the role of education as something really, really important, not only at our universities, but also in all sectors, because we have a continual process to educate people in general and professionals in our field also. So, and the UN role is something really important to put all people together, and I think people in the audience also can collaborate and think together. So thank you, Monica. Just to be brief and to put in a nutshell all the main ideas.
Thanks very much for that, Vanya. And well, I'll turn over to Vic now and give you the opportunity from your perspective, Vic, to give us a few of your perspectives on what you've heard so far.
Thank you, Monica. I hope everyone can hear me. I want actually to hook on what Bob said and Vanya, because at the SIDS, the small island development states, we have exactly this problem. We're all talking about innovations. We're all talking about development and sustainability. But those countries want to innovate. We have really knowledge has been enhanced, has been performed, and etc., etc. We are doing our best. But the more important thing is that the basic tools which are needed to innovate are missing in certain countries. And if you're missing the basic tools, how will you innovate? How will researchers research their and state their novel views, etc.? What we are seeing now is that all developed countries and the undeveloped countries are getting the waste, and the developed countries are making the rules. And the undeveloped countries should perform all those rules, but not having the basic tools. And I think that's a big problem, a problem which we should also tackle, because we want to go further and also transform. At least we need to transform urgently to meet the SDGs, to work on our green chemistry and sustainability, to work towards biodiversity and climate change. It's all there. We are willing to do that. But if the basic tools are missing, we are nowhere. So I think that's one of the statements I want to really stress out here, because that's really a huge problem, which, yeah, we can talk about everything, but just look at those countries as well and give them the basic tools. Thank you.
No, thanks for that very powerful reminder, Vic, and we do need to certainly keep that in mind, and it has been called for over decades through the UN's calls for capacity development and technology transfer, South-South cooperation, every mechanism you can imagine. So this holds true also for sustainable and green chemistry. So thanks everybody for giving those perspectives. And if I can ask the entire panel to come on so that we can see everybody and have this sort of online virtual sense of a real panel. So everybody come on so that we can see you and we can have a bit more of an interpersonal interaction here on this panel. I've got a bunch of questions that I'd like to sort of pose to you and give a little bit more time to really sort of hone in on a number of key areas. There's a really important aspect that almost everyone has brought up, and that's the role of both education and academic institutions in supporting the transformations toward green and sustainable chemistry. And so I want to turn to a few of you, certainly to Amy Cannon and to also to Bob for perhaps making some comments on this, and also to Vanya. So I want you to think about how you can look at academic institutions. How do we make sure that we're covering the type of education that is needed for governments and businesses and citizens to learn about green and sustainable chemistry? So Amy, let's turn over to you for a few comments from your perspective.
Yeah, sure. Thank you so much. And I think Vanya and I were speaking the same language around education, and that's sort of central and necessity. As I mentioned, education is just so central to supporting all the changes and the transition to green and sustainable chemistry that we're talking about. And again, if we're preparing scientists with the same skills as we've done for decades, then we're going to have essentially the same endpoint, the same product. So we really need to focus on transitioning our educational systems. Our focus at Beyond Benign is on that educational continuum from primary and secondary school through university level. And again, which is so important in supporting governments, businesses, and citizens to engage and support the adoption of and the design and innovation of green and sustainable chemistry. So on this continuum, really, academic institutions are, I think, one of the most essential pieces in the training of scientists and professionals that are prepared with these skills to address hazards and mitigate these impacts at the design stage of a product lifecycle. So I think universities and academia have a central role to play here and can really help to lead change in chemical industry and throughout society. I'll just mention really briefly a program that we have at Beyond Benign called the Green Chemistry Commitment. We're really fortunate to have global participation. It's growing, and we're really actively looking for more global partners for this program and an additional one, because we see this change is needed throughout the globe. We are a US-based nonprofit and really wanting to engage throughout the globe. So the Green Chemistry Commitment is aimed at departmental and institutional level change in chemistry education, recognizing that there's a need for fundamental and really systemic change. This program supports academic institutions to make these curricular and educational changes and really transform the way chemistry is taught and practiced. It's a voluntary, flexible program, and it's really, you know, and again, ultimately aimed at affecting systemic change. There's wonderful examples from our Green Chemistry Commitment signers from across the globe, from Africa to some newer signers in Europe, you know, that are really great, wonderful examples of implementing this change. And I think that they are the leaders on the ground and in those regions that are going to catalyze this greater adoption. I'll just, again, we have a second program which is called the Green Chemistry Teaching and Learning Community, and it's an online community platform and that we're building out currently. We're actively seeking global partners because we see a growing need to support this green chemistry education community, and we'll be, you know, it'll be essentially a place to share resources and tools and also seek mentoring for really developing out those leaders. Because I think like the potential that green and sustainable chemistry has on, you know, on how chemicals are processed and created is absolutely immense, you know. So it's a proactive upstream solution to addressing sustainability through chemistry. And again, Achim said it wonderfully in an opening presentation. You know, chemistry has this potential to address these challenges such as climate change at the molecular level. So, you know, for example, if a chemist is shifting towards a bio-based solvent, there's, you know, in one study, there's a 97% reduction in greenhouse gas emissions. Or say the example of, say, a greener technology, a breakthrough technology, such as a new class of refrigerants. These can really they can reduce the inherent global warming potential of a chemical product. You know, and these are chemistry solutions. You know, this is what how chemistry can tackle these challenges head on. And so the more that we can prepare these scientists and professionals with these skills, the better off we're going to be. The more breakthrough technologies we're going to have, the more shifts in behavior change that we're going to see. So and essentially have a significant change in chemistry and industry as a whole. So.
Great.
Thank you.
No, thanks very much for that, Amy. Some really great perspectives there. Vanya, perhaps you want to carry on and talk about some opportunities for, you know, green and sustainable chemistry innovations from an emerging economies perspective. We had Vic talk about the developing countries, and particularly the SIDS nations, but emerging economies are somewhere in between. So do you want to give us a few perspectives?
Yes, thanks, Monica. Amy, Vicky, Achim, Rafael, Bob, because I think you put very important aspects, and I would like to start talking about universities, because I'm from São Carlos, Federal University of São Carlos in Brazil, and as you know, it's a bit different from Germany and also from the UK, and so it's important to consider this, let's say, differences that can be also very useful. But as we know, I'm going to talk, first I would like to say thank you to Evelyn Araripe, a researcher working with me, and she's going to share some references with the audience too. And I am answering based on some work that are works, because they are plural, I am developing with some colleagues from Germany and also from not only Brazil but the UK. And for that, I would like to say that universities traditionally have focused on teaching, but we need to rethink about our role today as educators. Why? Because we need to prepare not only for today the professionals and citizens, and so there is a demand for a more contextualized education of chemists, but also other professionals, integrating, I would say, and I would like to highlight, the human sciences and economics to provide a more holistic and critical understanding of the reality. If we understand the reality, we can project a better future. But the future is about today. So how to understand today? And we need to include, to educate people or professionals, including creating awareness of the normative character of green chemistry, as I mentioned before, sustainable chemistry, and industrial application, and the many facets that we have of chemistry. And this is a prerequisite of or for understanding that and how the chemistry relates to industrial products and processes can and must change to become a larger and also sustainability block. Conceptualizing chemistry courses, for instance, just a moment, because I'm seeing something pop up here. Yeah. That means for real transformation towards sustainability implies not only understanding deeply how to produce and use greener materials or techniques. The implications of such products and methods for a more sustainable social environment can be detailed and problematized when we have a didactic model. When this model starts with a broader questions. For instance, I am giving a kind of example. If a material or technology is more sustainable, and to introduce the concept of renewables, a case study based on the rubber cycle in the Brazilian Amazon could explain not only the technical aspect to obtain a biopolymer and also the green chemistry principles, but if the effect of the extraction of latex itself is a guarantee to produce a greener material or not. So we can, that is really important to start with the historical facts, ethics, and the relevant elements also involved in the production of, for instance, this biopolymer, including tires, which heavily impacted the way of life on the globe. But the tire, it's not a problem per se. So understanding not only the source material could result in a better appreciation of chemistry and its products, instead of considering something simply linear or certain per se. So what is important? Having a broader educational approach that can be seen also in some courses that we are involved. I would like to highlight, for instance, the professional master course at Lofana, integrating topics as renewable materials, metals, water, circularity, and the biocircular economy. And we are also transforming not only the curricula, but the intention is to invite people to be transformed, and we are being transformed in this process too. So we have the same at my university in Brazil. We just launched a course 1 year ago that is online about green and sustainable chemistry in Portuguese and English. And of course, for university, it's also now we have a role. It's not only about basic research, but how to apply the research, and we have to do that. So we have a role also as a stakeholder, and also producing patents or licenses. Yeah, just to about the time.
Yeah, no, thanks, Tanya. We have quite a few other questions coming in from the audience and other perspectives that we want to hear as well. So great that universities in Brazil are doing some really good things. Bob, I'm going to ask you to quickly respond to this question as well before we move on to a slightly different topic. Do you want to take a stab at this one too? Bob, can you unmute?
Okay, now, can you hear me now? Sorry about that. Yeah, I just wanted to talk about a few more resources that governments and businesses may have to get more acquainted with the concept of green and sustainable chemistry. I mean, the German ISC3, the International Sustainable Chemistry Collaborative Center was mentioned. They do run an innovation hub, and they also include a research and education hub, which was already mentioned. For businesses, I think it's worthwhile mentioning the GC3, the Green Chemistry and Commerce Council, because it's especially relevant for businesses because it's a collaborative effort across all industries, sectors and supply chains to work towards the commercial adoption of green chemistry. So for businesses wanting to be more active in this area, that's a good group to engage with. And their website also provides publication and resources on the topic. I want to just briefly come back to some work being done at the OECD. I mentioned previously that one of the priorities, first steps, is to make sure that the concept helps actually move towards safer chemicals. And in that context, the OECD developed the substitution and alternatives assessment toolbox, given that one of the drivers for innovation is regulation and hence substitution. So the question is, what is going to be a safer alternative? And so this toolbox is a compilation of resources on substitution. You will find guidance documents on how to do alternative assessment, as well as practical case studies. And continuing on the topic of safer chemicals, we just earlier this year published a guidance on key considerations for the identification and selection of safer chemical alternatives. This is a guidance document that actually defines what is a safer chemical, and it provides recommendations for how doing your hazard assessment, how doing your exposure assessment, how doing comparative hazard and exposure assessments, and how do you integrate them to be able to select a safer alternative. I saw in the chat there's a number of questions about plastics, because a lot of the, let's say, visible issue of chemistry today is the introduction of plastic material into the environment, and so chemistry, of course, here plays a big role as well, and we are currently working on considerations for sustainable design of plastics from a chemical perspective. So both in terms of what are the polymers that you want to use, and what's the role of additives, and how can we develop or design plastics that are more sustainable, both from a point of view of safety as well as a point of view of recyclability, looking into circular economy issues. But that is going to be for hopefully later this year. One of the issues that we also want to tackle with these considerations is how can we help the finance sector to decide what innovative solutions to finance and to support. And so we hope that these considerations will have an impact in that direction in the future. Thank you.
Yeah, great, Bob. No, thanks for that. Some excellent points, and thanks for picking up on some of the questions that are coming in on the chat box. We're starting to move toward the bottom of the hour, as it were, and we still have quite a lot of interest and quite a few questions that I want to get to, and people that I want to have an opportunity to continue answering the questions. So, Rafael, I'm going to change tack a little bit, and perhaps you can tell us a little bit about what are we talking about in terms of the market potential for green and sustainable chemistry from industrial perspective. You talked about the fourth industrial revolution. What is what does the market look like? And then I'll go to Vic with a separate question. But do you want to just touch on that for a minute?
Yes, thank you for the question. I think before doing that, if you can give me only 1 second, I would like to make one remark on something that has been said before between Vania and Amy on the role of education. I think indeed education is a very, very important element, but I would like to give also an additional point in the context of the fourth industrial revolution that is basically as important as it is to educate ourselves, humans. Let me go now a little bit beyond. It's a little bit very important as well to ensure that this kind of frameworks and education are start putting as well into the new digital systems, talking about AI or talking about quantum chemistry. So I know it looks a little bit futuristic, but actually that as we think into the future, it's very important, correct, that we start mingling these two things, correct, human and digital, correct. So we start ensuring that is actually the education is indeed critical. To your question, I think, Monica, on the market potential, I think I will go back to Achim's point, in which I think is very clear that we might argue about the time, and we might have different views of the time, different companies, or maybe as also Vic was saying before on the realities of different parts of the world. But the reality is that in the long term, the opportunity simply is the market. There is no other market than a sustainable market. So nothing that what we do today that is not sustainable will be living or standing in the future, and it shouldn't be. So I think we are going through this journey, as I said, of carbon, circularity, and safer. And I think we need to encompass all these massive challenges. But as an economist, having the honor to look into our industry has been at the core of any industrial revolution. And I think we are actually at the core of the solution of the next industrial revolution. So I think the sustainable market potential is fundamentally the market. The market, I don't know when, depending on the areas, depending on the geographies, but I think the sustainable opportunity is enormous. And it's basically saying, as Achim was saying, business as usual is not an option. So I think that's where we are moving forward and where we need all to push forward. And I also look in Tatiana, I agree. We need to start putting these frameworks. I think it's very important to discuss what is the right and how do we engage moving from, because I think we all look into that and into how to solve that. What is the transition framework that enable us to do that in the most efficient manner? Sorry for the long answer, but I hope I answered your question.
No, thank you very much for that, Rafael. And I want to just sort of pose one more formal question to Vic, and then I'm going to wrap up because I think we are running out here. Vic, you mentioned from your perspective the SIDS countries, the small island developing states, and we all know, I think, or most of us do, that there's a program called the Samoa Pathway, which really talks about sustainable consumption and production and the management of natural resources and poverty eradication. Can you perhaps very quickly give us a perspective on how solutions in green and sustainable chemistry can offer, SIDS through the Samoa Pathway more upstream management of chemicals and waste, perhaps? If you can just comment on that, please. Vic, have you unmuted yourself there?
Yes, I'm on mute. It's working a little bit slower. Thank you, Monica. Yes, looking at this SIDS, we can say that one thing is very important: awareness. Awareness is one of the things which, if you don't have awareness, you can start anywhere. Awareness, laws and regulations, in all those countries, this is a problem. It's coming very slowly, and you know, governments are, you know, in conflict with each other, political strategies, etc. Those are very well things which should be pointed out and are also very important to look at. Another thing is knowledge. Knowledge in those countries should be, in general, should be developed more. I'm also at university. I'm also in a group, and I have my own group. Enhancement of the knowledge. I mean to say, to have sustainable, green and sustainable chemistry, you should know what is new, what can you do differently, have the library and the literature access to know what is new, because if you don't have access to those literature, then you don't know nothing. And this is also a big problem in those countries, and we are suffering about, you know, you don't have this contacts, and you don't have the financial support to have this literature. Those are very expensive. So that is one thing. So we should enhance. And again, I will stress out again, basic tools are really important. I will give a small example. Getting your food and your food products or the starting materials to produce your food are coming from abroad. How are you going to test if they are good, if they don't have these pollutants? This rich country know that. They know that we don't have these testing facilities, or they are very scared, or you know, not working. How you will test it, and how do you produce something that is good food if you don't test your starting material? Yeah. So those are basic problems, and I think that is something we should work on. Thank you.
Okay, super. Well, I live across the street from a lovely old church, and the bells just rang. So we've technically hit the bottom of the hour. So what I'm going to do is do a little bit of a speed round and ask each of our panelists to give me and give all of us that one sort of take-home message that you really want us to remember from this panel. So thank you, everybody, for all of your excellent questions in the chat box. I think we need a longer time, so let's everybody start. I'll start with Tatiana. What's your one take-home message? Very quick, one sentence.
Wow, one sentence is challenging. There is planetary urgency to stop pollution at source. It's urgency. There is urgency for all public policymakers and regulatory bodies to deliver and comply with their obligations to protect people and the environment. There is urgency for businesses to substitute to safer alternatives, and to invest in materials that are not harming people and environment. And there is urgency for research as well to safer products.
Yeah, that's a few take-home messages, but really, really good ones. Rafael, over to you.
Well, I think, as Tatiana, I think COVID-19 reminds us that nature is much more powerful than humans. We shouldn't never forget that, and we should just basically use technology, science, chemistry, green chemistry, sustainable chemistry to solve the next one. So let's work together for that.
Great, thanks for that, Rafael. Achim, over to you. Turn on your microphone, Achim.
Sustainable chemistry education is key, and UNEP presently is working on a manual on this topic. So please engage. It is under preparation. And lastly, making sure that green and sustainable chemistry make a difference. As Bob pointed out, so we need better indicators. We need action plans to also hold stakeholders accountable in taking forward this amazing concept.
Great, fantastic. Thank you. Vanya, over to you.
Thanks. So I think strengthening collaborative innovation or circularity from local to global perspectives, that is means local. And the present and future upcoming state of art relates to green chemistry and sustainable chemistry transformation, put in a nutshell, okay? Of a stronger biocircular scenario needs to focus on the outline hybrid integrated models to advance and provide critical solutions to promote sustainability, from resource management to products, process, service, that or which can prevent problems concerning pollution, scarcity, and unbalanced distribution of goods. We need to be fair. We need to face the reality to project the future. Thank you.
Thanks, Anya. Amy, over to you.
Yeah, you probably know my message as that central role of chemistry education that plays in all of addressing all these challenges. But I think one thing too, in addition, is that partnerships that's outlined so well in that final UN Sustainable Development Goal is global partnerships are required. I mean, we can't do this alone. So, and this was a great start. So thank you so much for bringing this global discussion together.
Super, thanks for that, Amy. Vic, your closing message for all of us, and then we'll close out with Bob.
I would say SDGs are not will not be fulfilled if we don't transform and teach our upcoming youth, etc. So please try that one. Thank you very much.
Fantastic message, thank you. And Bob.
Yeah, thank you. So the success is going to be dependent on good regulation on one side and support for innovation on the other side. But the first step is that I think all countries will need to have basic chemicals management systems in place for sustainable chemistry to take off. Thanks.
Great, thank you. Well, thank you everybody from the panel. I think we've had a really fantastic discussion, diverse points and perspectives coming through. Sorry to everybody online, we just didn't have enough time to go through all of your fantastic questions. And I think this sort of calls for perhaps a phase 2 or a continuation of this conversation, because it obviously has a lot of interest from everyone who's been putting in their fantastic questions. So thank you, everybody. You've made some fantastic points, and I'll provide my summary to the organizers so that we perhaps post the summary online. But we've run over time. You've been really indulgent. We really appreciate all of your hard efforts and the time that you put into preparing for this and your time in the panel today. So without further ado, I'll hand myself and all of us back over to the organizers. And thank you again.
Thank you.